My name is Mukesh Kumar Dansena. I am pursuing a master's in mathematics at IIT Guwahati. Today I will try to explain about limits. I want to tell you about limits using real life world examples so that you can better understand and relate with it so that you can feel you can you can relate it and understand better. So what is limit? Let us consider a room, closed room, where a person is standing, and where a person is standing, and we can assume that room, all the gates are closed in the room, so person cannot go beyond the room. So the limits of for that person as the walls, and he cannot go beyond the walls. So the limits are defined for him. So we can relate it with similarly we can relate it with functions. So let us take a function fx and considering a function fx where fx equal to x square, and I will say when x is close to 0, I mean when x approaches to 0, where the function will go, where the function approaches. I want to know that, and that's limits means for a function. So when x goes to 0 for that function, fx will also goes to 0. That means we can write it in symbolically that x goes to 0, x equals to 0. And in general, we can say when x goes to a, when x goes to a for arbitrary function, the fx goes to L, that is L is limit for it. So we can say that this L is limit for the function fx when x close to 0, when x closes to a for in general. So and symbolically we write it as limit x tending to a fx equals to L. This is symbolic representation of the limit. Now we can understand better with some more examples so that we can be more familiar about limits. I am considering another example fx with some other behavior. One when x is less than 0 and let us say 2 when x is let us say x is less than 0 and x is greater than 0, then function value is 2. Now I am taking a graph so that we can understand better. Now I am now when x is going to 0, when x is going to 0, I can see here when x is going to this sorry I have to first draw the graph for function. That means function look like that when x is less than equal to 0 and when x is greater than 0. So here you have to be careful about that. At x is at x equal to 0, who is at x equal to 0, who will not be there. That means therefore I am open circle is there. That means 2 is not included for x equal to 0, and here 2 is 1 is included for x equal to 0. So this is the function. Now when x is going to 0 from left hand side, when x is going to limit from left hand side, we can see that function value is 1 for x coming from left hand side, and when x is coming from right hand side, the function value is 2 but not, as I said, but at not equal to 0. So we can write it symbolically. We can write it as symbolically x tends to 0 minus for left hand limit and the x which is 1, and when limit x equals to 0 plus x equals to 2, and when limit at x equals to 0 x equals to 1, because at 0 the function is defined to 1. So we can clearly see that the function of left hand limit and limit of the function is equal, but limit of right hand limit is not equal to these two. So we can say that limit of the function does not exist, because for the limit exists if and only these three values should be equal. If not equal, we can say that the function is not has not limit. Now I am taking another example. We can also understand better that, because here some have a doubt, some have doubt that these two. I am taking another example of x. Here one when x is greater less than 0, and 0 when x is equal to 0, 1 when x is greater than 0. The graph of the function is like that. When x is equal to 0, let when x when x is less than equal to 0, at 0, this is not defined at 0. At 0 the function value is 0, and for another value of x the function value is 1. So here when x is approaching to 0, when x is approaching to 0, our left hand limit our left hand limit is 1, and when limit x tending to 0, that means that limit of function at 0 is 0, and limit of function from right hand side, that is right hand limit, is 1. Here left hand limit and right hand limit both are equal, but 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 limit of a function is not equal to the left hand limit or right hand limit. So in that case also limit of a function does not exist. So now I am going to take some more examples so that we can learn how limits can be calculated. Let us take equal to 0, x square minus 4 and x minus 2. Let's take the limit at 2. When x is closest to 0, 2, here function f(x) is, here we can here let us function f(x), x square minus 4 and x minus 2, their function is not defined as 2. But we want to know the value of what value of function when x is closest to 0, when x is near 2, when x is near 2. So let us try to calculate left hand limit and right hand limit or limit of function, so that we can get the limit of the function. So I am first calculating the left hand limit for the function x square. First I will calculate whether limit. Let us first calculate limit of 2. But here I can see that at x equal to 2, if I put here 2 and put 2 here, this is the 0 by 0 form. So we have to do some manipulation, so that we have to make manipulation so that we should not have to get this type of infinite form. So let us try to some manipulate this function. Something I am going to write a function in something different way. You can also write this function like that. Because x square minus 4 is the same as x square minus 2 square, which we know that the formula a square minus b square, which is equal to a minus b, a plus b. So using this formula I am going to manipulate this function. Okay, so here x is a and b is 2. Okay, then x minus 2, x plus 2, x minus 2. Here x minus 2 we can cancel it out, okay, by dividing. So I am cancelling it out and rewriting this extending to 2 x plus 2, and putting this limit to the x, we will get limit 4. Okay, so the limit of this function is 4. Now now I want to tell you about something algebra of limits. So let us algebra of limits. What if functions are in multiplications or addition like that? Let us when fx is a function and gx is a function. So what is when if I want to declare the limit of function fx plus gx, so when x is tending to k, to calculate the limit of the function fx plus gx, this is same as we can also find limit by limit x into a individually. That means limit can be limits can be put inside for two functions in addition, or also for subtraction. That means limit x minus limit x into a. Can calculate like that by splitting it separately. Similarly, for limit x into a fx into gx minus x minus a fx into limit x minus a gx, and similarly for division. Okay, so this is the algebra of limits, and let us take some examples for that and see some examples how to calculate if the functions are like that form. And x equals to x square plus x. Here we can I can consider as dx equal to x square or fx equal to x. So these are the two functions, and we have to calculate the limit of function fx. Limit of function fx. So I can calculate the limit of function by calculating say limit of gx separately and hx. Okay, so I will write it as limit x into a gx plus hx. As I previously told you that I can write its limit with separate for each function gx plus limit x into a hx. Okay. So if I say that I want to find limit of that function at x equal to 0, so let us I am erasing it and I will directly find the limit with this way. That means I want to find limit x tends to 0 at x dash function when x goes to 0. Initially, when I start the lecture, I also told that limit of x square, which was 0, and the limit of x is also 0. So the limit of fx will be addition of these two. So the 0 plus 0 is also going to be 0. Which is going to be 0 plus 0, which is equal to 0. So the limit of the function fx is equal to 0. So similarly, other examples of multiplication, subtraction, addition can also be calculated. So this is my lecture for today. Okay, thank you.